sure, your conscious mind can definitely influence your decisions and actions. I'm not trying to say it's not involved, but at the end of the day, it's your unconscious brain processes that are making the final decisions and actions.
The Rational View is a weekly series hosted by me, Dr. Alan Scott, providing a rational, evidence-based perspective on important societal issues.
Produced by Soapbox Media.
Hello and welcome to another episode of The Rational View. I'm your host, Dr. Al Scott. In this episode, I'm interviewing the lead author of a recent paper describing a new theory of how consciousness works. It's based on evolutionary principles, and it posits that we mostly go about our lives unconsciously acting and reacting with no free will in the present moment. The theory is that the conscious mind has evolved to enable reasoning and goal-driven behavior purely through manipulation of memories. In this theory, we have no direct control over our actions in the present moment, as our observations are always a few milliseconds behind. So this idea has interesting things to say about free will and first-person experiences. I hope you enjoy this interview. If you enjoy what you're hearing, please mash the like button on your podcast app. Please share the episode on social media. And please join me on our Facebook group, The Rational View, if you'd like to chat. Educated at Haverford College and Harvard Medical School, Dr. Andrew Budson is Chief of Cognitive Behavioral Neurology at the Veterans Affairs Boston Healthcare System, Associate Director of the Boston University Alzheimer's Disease Research Center, Professor of Neurology at Boston University School of Medicine, and Lecturer in Neurology at Harvard Medical School. Dr. Budson, welcome to The Rational View.
Thanks so much for having me.
I appreciate you coming on to chat with us about your work. Could you tell us about your background and how you got interested in neurology?
Yeah, well, believe it or not, I got interested in consciousness before I was interested in neurology. So when I was way back in high school, I just became fascinated by, understanding the mind and science, and how does the mind, tie into the cells in our brain, and, what's the biological basis of thinking and memory and consciousness and things like that. And when I went to college at Haverford, I actually wanted to tackle this problem head on, but I really wanted to do it in a sort of a hard science way. So I actually decided to double major in both philosophy, but also chemistry, to try to get at both ends of the problem.
Oh, wow.
Yeah, no, it was great. And
that's a very diverse course load.
Well, it was good. It was a good time. And, for example, my chemistry thesis was actually trying to synthesize a sort of a new antipsychotic medication that could actually, help to sort of correct consciousness that had sort of gone astray. So it was a very good experience to really help me understand sort of rigorous thinking. That's what I learned in philosophy, but also the scientific method and sort of what proof meant in both fields, in both philosophy and science. It was also a time when I met, a lot of wonderful friends. And one of them was Ken Richmond, who was a philosophy major with me, who would later join this project with me, and is one of the co-authors of the consciousness paper. So when I was getting ready to, finish college and go on to the next stage of my career, I thought very hard and long about, did I want to get a PhD in neuroscience or something like that? And at the time, the neuroscience piece that I was aware of, it was mainly looking at single cells or animal models. It really wasn't able to tackle these big questions, but I did know that people were making inroads looking at patients and what happens when they got different brain diseases. And it also pulled a side of me that is very devoted to trying to help people and make a difference in the world and things like that. So I thought going to medical school would be the right way to do it. But I knew entering medical school that I was either going to do psychiatry, neurology, neurosurgery. There was no doubt in my mind. And the way I figured out which one of those was actually really just hanging out with people and finding out like who were the people who were interested in talking about, these types of issues in sort of a rigorous, way. And it was the neurologists who were interested in having these types of discussions. So then I became a neurology resident, did my training, and then I did an advanced 2-year training in cognitive and behavioral neurology. So the part of neurology that is dealing with disorders of the mind, but again, from a neurology perspective. And that is mainly dementias, is mainly taking care of people who have dementias. At the same time, when I was doing my clinical fellowship in cognitive behavioral neurology, I wanted to start doing my research on consciousness. But I was very aware that I did not have a PhD. And I needed to get some rigorous training to be able to do this. I had done some science in college, some science in medical school, but none of it was the right type of science. And I looked around for different labs and who could I work with. And I ended up going to this conference in Tucson, Arizona called Toward a Science of Consciousness. Turns out it was the second conference they ever had, and it's now a conference that's been going, ever since then. It was back in 1996, and I went to this conference, and there were 2 things that happened that were really important. The first thing is I realized, at least from my perspective, there was no science of consciousness. It just, the field was just not there. And, there were good people working hard, making good strides, but it really had not congealed to like a coherent field of study that somebody like me could be like, oh, let's grab the textbook on the science of consciousness and let's take classes and let's figure it out. It just really wasn't quite there yet. The other thing that happened is I met this professor of psychology, Dan Schachter, who was actually at Harvard, but he was there at that conference to give a couple of lectures. And he had done pioneering work on understanding the difference between explicit conscious memory versus implicit unconscious memory. And he had actually authored the section on consciousness in this textbook of cognitive neuroscience edited by Michael Gazzaniga. And so I thought, this is the guy that I should do it with. So I did my a research postdoctoral fellowship with him, officially for 3 years, but unofficially, I hung around in his lab for 6 years to try to really, soak up all the information before I felt comfortable sort of going off on my own. And then sort of over the years, I, continued to work on experiments that were mainly memory experiments. And that's what I learned from Schachter. He's primarily a memory researcher, but anytime there was the opportunity to look at the difference between conscious and unconscious processes, or to look at the biological basis of, for example, the conscious experience that we have when you're trying to retrieve a memory and you say, oh, that's it, that's what it is. We did some work localizing, where is that conscious experience going on? So I've been interested in this field, for a very long time. And then what happened is that as I began to see patients with different brain disorders, whether they were patients with strokes or patients with different types of dementia, like Alzheimer's, frontotemporal dementia, dementia with Lewy bodies, I began to get sort of more and more insights about, what was happening to the consciousness of these individuals as they were suffering these neurologic illnesses.
This is good. I have so many questions for you. You mentioned localizing conscious processing to a region of the brain. Can consciousness be localized in the brain? Is this happening in one particular spot?
Well, in that paper, which I think was published around 2009, what we did is we, along with others, were looking at when you retrieve a memory, what parts of the brain are being active. In our lab, we use EEG. We put 128 EEG electrodes on your head, and we look and see where the signals are coming up. And in a colleague's lab, John Simons in Cambridge, England, he was using functional MRI. And both of us and other researchers as well were finding this parietal region. So the parietal region is sort of the top back of the head. And this area seemed to light up when people were consciously retrieving a memory. Now, what was fascinating, and what we also did is we said, okay, well, this is interesting that this parietal region is lighting up, because the parietal part of the brain is not a traditional part of the brain that's necessary for remembering things. For remembering things, it's much more the hippocampus, which is deep in the temporal lobes, and its sort of immediate connection. So the famous patient Henry Molaison, who is known by his initials HM, the problem he had was that his hippocampus was removed on both sides, and he became amnestic. But here we have this parietal region lighting up. What is going on with that? And we then looked at patients that actually had lesions in their parietal lobe. So they either had a brain tumor resected in that area, or they might have had a stroke in that area. And we looked to see, well, how were their memories? And it turned out their memories were just fine. And but the clue that we had is when we asked these patients, tell us about your memory. They said, that they felt less confidence in their memory. They really didn't feel they were sure that they could remember things well. They did not have that conscious aha moment. And so that was one of the clues that the cortex can be involved for conscious retrieval that's separate from the unconscious retrieval portion. And so when you ask, can consciousness be located? At that time in 2009, my answer was, well, conscious retrieval looks like it's up here in this parietal region. But I knew it just didn't sort of make sense that all of consciousness would be located there. And the theory that we put forth in this recent paper is that different parts of the cortex, the outer layers of the brain, are involved with different aspects of consciousness. So memory retrieval might be in the parietal lobe, but visual awareness, I'm quite sure, is in the occipital lobe, where the visual areas are, et cetera, et cetera. So different aspects of consciousness are in different parts of the cortex.
Yeah, it's a distributed process in that frame, and this, of course, brings up what many philosophers would call the binding problem of how do you have a unified conscious experience if it's happening in all of these different places? Why do you experience a unified awareness. And I've talked to several experts in the field of consciousness, and there, as you say, there's neurologists, there's philosophers, there's chemists, it's such a broad field, and I think it's because we just don't understand enough to ask the right questions at this point. And it seems each of them has a different idea of how consciousness arises. I've now maybe want to go a little bit towards the paper that you recently put out. I've read the press releases surrounding your paper, and I think you seem to be espousing a theory of what I would say is retrospective awareness, and that you're working in memories. Could you give us an overview of your new theory of consciousness?
Yes, absolutely. So, people had been aware for a long time, actually, ever since like William James in 1890, that sometimes consciousness seems to appear in like the wrong order, or it's like you're sort of aware of things consciously that happened in the past. So William James, actually quoting a neurologist, Exner, talks about how sometimes the clock can finish chiming, but then after the clock finished chiming, we can pay attention to it in the past and count off the strokes. And there's the more common example that I think we all have when you're at a cocktail party and you suddenly hear your name mentioned in another conversation, and you can retrospectively pay attention to what was said at the earlier part of that sentence. And so the question is like, well, were we aware of the clock chiming, or were we aware of the earlier part of that sentence or not? And then you get into some experimental results that are very interesting, where if you show a stimulus on the screen by itself for, say, 50 milliseconds, you can see it, no problem. Your perceptual system can take care of seeing that. But if you show that stimulus, okay, and then you take that away, and then you show another stimulus, say, 50 milliseconds after that, then this later stimulus can affect your perception of this earlier stimulus. And it's like, what is that? And these are called post-dictive effects. And the example that I think will make the most sense to your listeners has to do with motion pictures. So it turns out that especially if you're looking at a movie like when I grew up, in the 70s and 80s, watching movies in the movie theaters, those are actually on film, multiple frames. And the fact of the matter is, our perceptual system is perfectly capable of seeing any one of those individual frames as a still image. And if I showed you those images separately for the same amount of time they're on the screen, you would see them as still images. But when we watch a movie from these films, we don't see a series of still images. We see continuous smooth motion. And why is that? And it's the same reason that somehow the later image comes, and then we interpolate what happened in between. So instead of seeing like the hand like this and then the hand, moving forward, we actually, our brain interpolates what is happening in between those two images, and we actually see smooth, continuous motion. And this has been shown experimentally in the laboratory. And the thing that is just wild about it is that, like, if you show them separately, they're two separate things, but you show them together, the brain has the smooth thing in between. And so when I began to sort of like put all these things together, like how can this make sense? What I realized is that the only way that it would make sense is if our conscious perception was actually a memory. and we were remembering something that happened. But not only were we remembering it in a straight sensory way, we're remembering it in the way the brain likes to do things, which is there's these bottom-up sensory processes, which is the raw information, say, coming in through our eyes. But then there's this top-down information where the brain is interpreting what it's seeing using its past experience and past knowledge to make sense of the world. And so then our conscious perception is like this mashup between these bottom-up sensory processes and these top-down episodic memory and semantic memory processes. And I say episodic memory when I'm talking about memory for episodes of your life, your own personal experience. And I mean semantic memory when I'm talking about your memory for facts and what things are and what objects are and things like that.
Yeah, terminology is an issue when we're talking about consciousness, I think, because, consciousness is so many different processes and memory is so many different things. We're very limited on our terminology, I think, and this sort of clarification is necessary for us to make progress, to separate semantic memory as a different thing from episodic memory. It's completely different potentially. So we have this top-down processing of memories, and this is where the consciousness comes about. Can you maybe expand a little bit on what you're saying there?
Yeah. So basically, what we ended up thinking is that our conscious awareness is actually our remembering things. That's what it is. It's our ability to keep things in mind in what we call working memory, which is the ability to keep information in mind and manipulate it. But it's influenced always by these other types of memory processes that are also conscious: episodic memory, semantic memory. And the real insight is, people used to think, so people were aware of these memory processes, for many, many, many years. And people used to think, well, there's consciousness, and then some of these conscious, perceptions, items, whatever, get remembered. But what we argue is, it's not that there's consciousness and some things get remembered. It's that consciousness is the same thing as these explicit memory processes. There's no difference between the two. There is no consciousness that's not part of memory. So there's always a little bit of a delay. And then the next part of the theory, it's like once you wrap your head around, this sort of conscious perception, then the next part is, well, what about conscious decisions and conscious actions? And so we argue these are also memories. These are memories of unconscious decisions and unconscious actions. And although it starts out, you think about it, you think like, well, that's just ridiculous. How could that possibly be true? But then I don't think you have to think very hard about all sorts of things that you do that, number one, you're not paying any attention to when you're doing them. I mean, it's like, how come you can be driving and suddenly you find yourself, I missed the turn, It's like, well, how did that happen? Or how come you can be driving and you can be engaged in a conversation with a friend and you don't remember the last 10 miles that you drove? But I argue you weren't paying attention. You weren't really conscious of it. Your unconscious brain processes were perfectly capable of doing that little stretch of driving. Now, if something it requires your full conscious awareness, like you're driving in a torrential downpour, well, then you got to pay attention and you can't talk to your friend at that time. And then the other way that, again, to me, the more I think about it, it just seems so intuitively obvious. It's like, have you ever, tried to do something and found that you weren't able to do it? Like, have you ever tried to diet or to exercise every day, or, to do whatever you're trying to do on your New Year's resolution? It's like, well, if my body is completely under my conscious control, I should be able to just make a decision and carry it out. But here I am eating the entire chocolate cake. It's like, why is that happening? And again, we argue it's because, sure, your conscious mind can definitely influence your decisions and actions. I'm not trying to say it's not involved, but at the end of the day, it's your unconscious brain processes that are making the final decisions and actions.
That's very interesting. So this suggests that we don't have any free will in the present moment, but only in a roundabout way can our consciousness impact on our actions.
Well, I mean, I'm glad you brought that up. So I would argue that the you that we are talking about is both your conscious mind and your unconscious brain. So I would never say that just because your unconscious brain processes are doing things, that it's not part of you. That's still part of you. That's still you. It's just that, sure, your conscious mind is only in charge in a roundabout way, but you're still making the decisions because you are your unconscious brain processes as well. And just one little thing about free will. So the problem with free will is the problem of determinism. And so the problem of determinism is that if, as I do believe, you can reduce all of the brain processes to chemical, remember I was a chemistry major, to, chemical, electrical, physical reactions. And we know that those reactions obey, Newton's laws, other, laws of physics and chemistry. And if that's all just happening from those laws, we have external things that influence us as an organism. There's things internally with us as organisms that may influence it. But you can describe everything, if you had enough time and you had enough expertise, you could describe every single thing that the brain did in terms of just physical chemical reactions. And if you could do that, then you could completely predict exactly how I would behave and act and what decisions that I would make and how I would feel just based on chemical, physical reactions. And there would be sort of no need for any sort of consciousness to be there at all. That's the problem of determinism and free will. And I want to say very clearly that whether or not it's the unconscious part of you that's making the decisions or the conscious part of you that's making the decisions is actually not, it doesn't say anything about this deterministic problem. We have this deterministic problem either way. So believe it or not, my theory doesn't say that you do or do not have free will. It's really orthogonal to that particular problem.
Oh, okay. Yeah, no, that's very interesting. And the philosophical impacts of that thinking are very interesting. That, you're basically saying there's no spark in the machine. It's a machine, and our free will is dependent on the concept of determinism to the extent of what you think free will is. Yes, we are acting in accordance with our goals. So that is one aspect of free will. We are not a magical entity changing the deterministic evolution of the universe, but we are acting in accordance with our goals. So it's very interesting when you get to the philosophy of what does free will actually mean in that area. And to me, it comes down a little bit to what is sentience. How do you define sentience, and what does it mean? It seems like if our awareness, our consciousness is working on memories, then we're actually not consciously present in the moment, which is really interesting, and and seems to make sense with the observations, which is very cool. And it's just a very odd thing to me. What are the implications for sentience in other beings, or even in artificial intelligence from this interpretation? Is just the manipulation of the memories sufficient for sentience and awareness?
Yeah, no, it's a great question. And the thing I confess that we don't talk about very much in the paper is about the personal subjective experience, which I think is important because in a very real sense, it's the essence of sentience or consciousness. That we are having an experience. And I do believe that having an experience is important. And I don't know exactly why, but I've begun to develop a hypothesis that the experience is important to help us to learn from prior things that happen to us, and to change our behavior in the future. And so an example I would use is about how we learn from something that we did that didn't go well. So in the obvious type of example, let's say that, you're trying to get a drink of water from a mountain stream, and a tiger comes up and chases you, and maybe even maws you, and you get like a scratch, like a big scratch on you or something like that, and it causes pain. And because it causes pain, not only do you remember that in an episodic memory sense, but this also causes classical conditioning. And, you learn at a very deep intuitive level that, oh, this stream is a dangerous place for me to drink because I could be attacked by a tiger. Okay. So let's talk about, why is it important to have an internal awareness? Because that type of classical conditioning could go on even without an internal awareness. And the thing I've been thinking about lately is about regret. When we regret something, we feel a sense of pain, right? Pain, discomfort, unpleasantness. It's a bad feeling if you feel regret. And with regret, it's the situation where you can, using your conscious memory processes, you can envision a future outcome that could have been, but didn't happen. And if you feel regret, it means either your actions or your inactions led to one outcome, but not perhaps the best outcome. And this causes you pain. And you can learn from this pain in the same way that you can learn from the tiger's pain. But this pain is completely caused in your mind. The regret pain is caused in your mind. And so my current thinking is that the reason that this subjective sense, the sentience, this internal feeling that we have of ourselves as an entity is important, because it allows us to basically have sort of much, not sort of simple physical pains and joys and pleasures and things like that, but to have these psychic And I just mean psychic, meaning in the mind, pains and joys and pleasures that are due to much more complex stimuli. But then it allows us to know, sort of which of these sort of complex stimuli and things that have happened to us, which are the good ones, which are the bad ones. It teaches us in this sort of intuitive way. And that's why I think that conscious awareness is important. And I do think from the anatomy that other animals have consciousness as well, or at least I would say they have the neuroanatomy for it. And let me just unpack that a little bit. So I spoke earlier about some of the different regions of the brain, the different regions of the cortex that can be conscious of different things. We talked about the parietal region as related to awareness of retrieval of a memory. I mentioned the occipital lobes as where visual awareness goes on. The superior temporal gyrus is where auditory awareness is taking place. And basically, I think that you have all these different cortical areas that are important for different aspects of consciousness. And if, as we argue in the paper, the cortex is the key to conscious awareness, then other animals that have a cerebral cortex therefore have the necessary neuronal architecture, the neuronal anatomy for conscious awareness. And to boil it all down, it looks, at least in terms of my understanding of comparative neuroanatomy, that all vertebrates have either a cortex or some very similar analogous structure that basically serves the same purpose. And because of this comparative neuroanatomy, we argue, following many others like Franz de Waal, that conscious awareness exists on a continuum in vertebrates. So vertebrates includes fish, includes birds, includes reptiles, amphibians, and all mammals. And whereas, for example, only animals, for example, like human beings, the great apes, whales, bottlenose dolphins, maybe only those animals have self-consciousness, self-awareness, know what it means to be a self. Those animals pass the mirror test, which is when you put a dot of something, say on the forehead, in a place that an animal cannot see it themselves, but if they look in a mirror, they can see it. Those are the animals that are aware, oh, there's something on my forehead, I should scrape it off or something like that. Other animals don't necessarily pass that test. Although, as we say in the paper, even that is a little more complicated. But basically, we think it's on a gradation. So some animals are aware of themselves as conscious beings. Other animals may just be aware of pleasure and pain and not much more than that. And we think there's everything in between. So consciousness is on a scale, a gradation. Certainly not every species has conscious awareness, but we think all the vertebrates have at least the requisite anatomy for consciousness. And before I be quiet and let you ask your next question, I do want to just mention that all of you out there who are saying, what about octopuses? Okay. I basically, my theory doesn't say anything one way or another about whether an octopus is conscious. And I have, seen the reports and read some of the literature on this. I certainly agree that octopuses behave as if they're conscious. And so I'm not in any way saying that other organisms are not conscious. All I'm trying to say is my theory predicts that all vertebrates would be conscious.
Interesting. Yeah, I mean, I've spoken to people that some people feel that it's a vast spectrum like yourself, through the tree of life. I've spoken to people that believe single-celled animals are sentient. I've talked to people who believe that consciousness is an intrinsic feature of the universe that life organizes. It's there's such a vast spectrum of ideas about this. So maybe what we need to think about is what differentiates consciousness from the lack of consciousness. What predictions would your theory make to basically identify the effects of consciousness? Is it only allowing processing of regret, or the sort of psychic planning, as you described? Is that the distinguishing feature of consciousness?
I'm almost sort of embarrassed to say, but our theory, it doesn't have a lot to say on this topic. I mean, the main thing I would say is to just go back to sort of the basics, and I mean, the main part of consciousness is it's this sort of subjective awareness, and it's it's like, how do we have to go back to the binding problem that you mentioned? It's like, how is it that instead of experiencing separate sights, sounds, smells, thoughts, feelings, how come we experience things all bound together? And there's a brilliant perceptual researcher in Australia named Heinz Hogendorn, and he has ended up coming to almost an identical view of conscious perception as we put forth in our paper, but neither one of us knew that the other one was working on this problem. And he looks at the binding problem of perception, because it turns out that like our color awareness comes before like our motion awareness. And it's like, even, to even see a visual scene in a coherent way, there has to be something special that goes on. And what he ended up arguing just from the field of perception is that our perception has to be a memory, because that's the only way that we can put all these things that in the brain are occurring at slightly different times on a millisecond scale and put them all together in a coherent whole. So, I have to say that, I was, brought up sort of as, both a philosopher, but also as a scientist, a cognitive neuroscientist, an experimental psychologist, a neurologist. I take care of people, with brain disorders. I see, unfortunately, in my patients with dementia, I think piece by piece by piece of their consciousness disappearing, and until they're basically in a delirium. And we argue in the paper that a delirium is basically a situation where people are not completely, but they're mostly operating on unconscious actions, that they don't have a lot of conscious control in any way over them. So to me, the idea that a single-celled organism would be conscious, or that the universe somehow has, sentience, I guess it doesn't fit with my understanding of at least what that term would mean as a physician and a scientist.
It sounds like you're very, very much a physicalist from your scientific background.
I'm not a dualist.
So you would believe that artificial intelligence, for example, could mimic the processes of consciousness, and we should be then thinking about the rights of artificial and intelligent systems. Is that have you thought about that at all?
Yes, and you are exactly right, that because I believe that you can boil it all down to biochemical processes, that there is no intrinsic reason why it could not be replicated in an artificial being. And now I think it's extremely interesting. I mean, I will say I'm not a vegetarian. Okay, I eat a range of foods, but I am very aware, since I wrote this paper, that I am consuming other beings that have at least some degree of consciousness. So, I guess I would say, yeah, at one time we're going to need to consider, artificial beings as conscious beings and what are their rights. But we don't need to go to artificial beings to talk about the rights of other conscious beings. I mean, we can just look at animals, and like I said, my theory would suggest that all vertebrates, have the potential, or actually have some form of consciousness. Not the same as human beings, but some form of consciousness.
This also bears on the question of how do we identify consciousness, and as you say, it's difficult to point to things that are outcomes of the effect of consciousness, and we're stuck. The best thing that that we have to distinguish between consciousness or awareness and not awareness is, say, the Turing Test, where you interact with something, and if it seems conscious, then maybe it is. Do you have any? Does anything come from your theory that could help us with this?
Yeah. Well, I love the story of Alan Turing. I saw that great movie. I can't remember the name of it at the moment. That sort of talks about some of his work during the war. And I've been interested in computers for a very long time. I actually built my first computer from a kit when I was in eighth grade. Did all the soldering and everything. Absolutely. It was a Heath kit for anyone who remembers those days. So I'm very interested in all that. But I don't think the Turing test is a test for sentience or consciousness. I mean, I think that's a test of, can you have a clever programmer? I don't think that's really the right test. I did want to just talk about one other thing that's in the paper that I think your listeners will be interested in, which is this metaphor that we use of a horse and a rider, that to sort of get at some of the things that we're talking about. And when I talk about, the relationship between the conscious mind and the unconscious brain, the best analogy that I can give is if we think about the horse as all of our unconscious brain processes, and we think about the rider as actually our conscious mind. And, in order for a horse to go from, say, Carson City to San Francisco, it needs a rider to sort of direct them and tell the horse where to go. If you leave the horse on its own, it's not going to go anywhere close to in that direction. But at the same time, you don't need a rider to tell the horse how to walk across a rocky field. It knows where to put its feet to stay stable and avoid from stumbling. You don't need a rider to tell a horse how to jump over a small wall or canter versus gallop versus walk or do any of those things. The horse does just fine. And just like, again, a horse and a rider, the rider may want to go in one direction, but ultimately the horse decides where one goes. And this is sort of how I feel is sort of the distinction between the horse and the rider, between our unconscious brain processes and this additional level of conscious control. The other thing that's very interesting is the unconscious brain processes are actually driving what our conscious mind is seeing or thinking about most of the time. And this is the reason that we argue that mindfulness is difficult. I don't know if you've ever practiced mindfulness, or if you do practice mindfulness. I do 12 minutes each day. I did my 12 minutes this morning. And it's hard. It's hard to, focus on my breathing or perceptions and not let my mind sort of wander, into all sorts of other things. And, again, this was sort of one of the clues I had that, like, if our conscious mind evolved to basically just help us control decisions and actions, then why is it so darn hard to control our thoughts? And so, uh, again, I think that the sort of horse and rider analogy can be helpful there.
Right. Being present in the moment takes on a whole new meaning when we're present in the next moment, or only present in the past, I guess. So this is a question I've asked other people in the neuroscience area. Do we understand how memories are stored, or where they're stored, what memories consist of in a physical sense?
Yeah, it's a great question. And I'm glad you asked. I'm going to plug a book I wrote with actually one of the other co-authors of this paper, with Elizabeth Kensinger, who is professor and chair of the psychology and neuroscience program at Boston College. And she and I wrote this book together called Why We Forget and How to Remember Better: The Science Behind Memory. And in fact, it was writing this book with Elizabeth that actually spurred a lot of the ideas that led to this consciousness paper. And so we do, I think we actually understand fairly well how memories are formed. Memories are changes in the synapses in our brain, the strength of the connections between neurons. That was something that Eric Kandel and other basic science animal researchers looking at looking at memory were able to tell us. And then it's through patients like HM, as well as experiments using functional neuroimaging, that has really helped us to understand how memories are stored. So for a conscious episodic memory, an episode of my life, say remembering this experience of recording this interview with you, I have the sights coming in through my eyes. I'm hearing the sound of my voice, the sound of your voice. I've been sipping coffee and water and different things during the interview, so I have those tastes and smells as well. And I also have different thoughts and feelings going on. All of that information is transferred into patterns of neural activity. That neural activity gets bound together in a part of the hippocampus called the dentate gyrus. It then gets transferred over to another part of the hippocampus called CA3. And I'm giving the names just so you understand that we really do understand at sort of a fine-grained level, how this works. And in the CA3 region of the hippocampus, it gets tagged with a unique hippocampal index, such that if, for example, I saw your face, say another day, maybe somewhere on the web, that image of your face could go down to the CA3 region, could help me retrieve this pattern of neural activity, which then gets transferred to the CA1 region of the hippocampus, to a neighboring region called the entorhinal cortex, and actually back out to the same cortical regions that were used when I had this perceptual experience. And it helps me actively recreate the sights, sounds, smells, thoughts, feelings of the original memory episode. So we actually understand quite a lot about it. And anyone who wants to learn more, that book is coming out February 1st, but is available for pre-order now.
Very good. I'll have to take a look at that. I'd love to dig into that because, there's a lot to unpack there. You're talking about synapse strength, encoding the memories, and then something happens in the hippocampus. And what I envision when you say this is that the synapses are distributed in the sensing areas all around the brain that are being affected by these events. How does the hippocampus pull all that together and store it as something that can be retrieved? How do you link to all of these distributed synapses in one localized area? What is linking?
What's linking them is actual connections. So the cool thing about neurons is that they have processes that are quite long. And some of the processes are like over a meter in length. I mean, they're just really long. And there are basically neurons that are going, from, say, the hippocampus to the visual center in the occipital lobe, or back to the auditory cortex, or back to the olfactory cortex, or back. So you actually have literally wiring or connections. And so if I look at an MRI scan of your brain, I can see both the brain cells and I can also see all the wiring. And the wiring probably takes up more room than the brain cells themselves. Almost if you opened up a lot of electronic devices and you see wires going everywhere, it literally is a lot like that.
Wow. Okay, so it's direct wires to the sensing areas and the processing areas.
Exactly. And then what's really cool, of course, is for memories that are very important to you, memories you're thinking a lot about, the synapses, the neurons continue to fire, the strengthening increases, there is protein synthesis that goes on, it can increase the number of connections and really make things permanent. And, we used to believe when I went to medical school, I was taught that we have all the brain cells we're ever going to have by the time we're 18 years old or something like that. And that's why you shouldn't do drugs. That's what I was told. But what we actually know now is that in some regions of the brain, including the hippocampus, we actually make new brain cells all throughout our lives. And we actually make more of these brain cells when we exercise. So aerobic exercise is actually very important. But the bottom line is that, memory happens through these sort of strengthening, and we're always ready to learn new things. We can grow new neurons. We can make new connections.
Wow, that's really cool. So we're getting towards the end of our time slot here, and I've really enjoyed chatting with you about your theory. It seems quite parsimonious with the data, and I think I'm on side with this approach. Lots to learn. But before we go, I want to I have a question I ask a lot of my guests. What sort of science fiction do you like? Do you read any science fiction as someone who's interested in consciousness? Is there anything that resonates with you?
Absolutely. Yeah, no, I love science fiction as long as it's good. I grew up reading Isaac Asimov and really enjoyed that, Ray Bradbury, a lot of the classic science fiction writers. And I really have enjoyed, now I'm blanking on his name, speaking of memory, the guy who wrote the Baroque series, you know what I'm talking about?
I don't have that one.
Yeah. So, but there's a lot of science fiction.
Have you ever read Blind Sight by Peter Watts?
No,
I
I
would
haven't.
recommend that for you. It's online,
Oh,
available
great,
online,
great.
a short novel, and it's about encountering a race of aliens that aren't conscious.
Oh, that does sound great. Oh, I'll definitely check that out. All right, Blind Sight. Yeah, fascinating.
So thank you so much for coming on The Rational View, Dr. Budson. Appreciate it. For spending your time here, I'm going to send you a Rational View t-shirt.
Awesome. I was looking at the one you're wearing. It looks awesome.
Thank you. Thank you. Much appreciated. Thank you. If you'd like to follow up with more in-depth discussions, please come find us on Facebook at The Rational View and join our discussion group. If you like what you're hearing, please consider visiting my Patreon page at patron.podbean.com/therationalview. Thanks for listening.